Groundwater depletion is a growing concern across India, affecting drinking water, agriculture, and ecosystems. But how does it influence the ability of plants and ecosystems to absorb carbon from the atmosphere and how this process is linked to the water cycle? A recent national scale study from the Indian Institute of Science sheds light on this crucial link between groundwater levels, plant productivity, and carbon storage. I am Dr. Anubha Jain, senior journalist with ETV Bharat, and today I will speak with Professor Sekhar Muddu from the Indian Institute of Science, Bangalore, to explore these findings and their implications for sustainable water and land management. Welcome to our channel, sir.
Thank you very much for having me for this session.
Yes, sir. So, sir, first we would like to know why was it important to study the link between groundwater depth, carbon confiscation, and the water cycle at a national scale rather than at individual locations?
So the groundwater, as you know, is a very important resource, and it's been abstracted quite differently in various quantities in India, and it's going through depletion. India is the biggest user of groundwater through anthropogenic sources. So considering that, and this groundwater varies differently in different parts depending on the usage. Having said that, the groundwater typically supports forests, grasslands, natural ecosystems in various manners, and especially during dry seasons. But humans have been using it for agriculture purpose, drinking purpose, and industrial purposes. So we thought that since we have wide variety of ecosystems across the board and uses are quite varied, we thought we should study at a national scale so that we get uh, fingerprints on which areas are doing okay, which areas have difficult stresses, and so on.
So, what do your findings reveal about how declining or in general groundwater levels affect plant productivity and carbon storage across different ecosystems in India? Also, does a falling groundwater pose challenges related to drinking water scarcity as well as broader environmental and economic impacts?
So, I mean, I'll put the other way around, second point of yours, where groundwater levels falling is an issue for not able to bail water for drinking purposes, which happens in urban areas, which also poses difficulties for agriculture because you want to depend on additional irrigation, which requires again more energy utilization if the groundwater levels go down. There is a strong connection between water, food, and energy nexus in which the groundwater is used. But having said that, the plants, we're talking about natural ecosystem, is also dependent on groundwater. During a dry season or during droughts, the only source of groundwater is the only source for ecosystem to utilize in their access to water and their growth. So, for example, any plant wants to grow, it uses the water and the carbon to grow. So, if there is no water properly available, the plant growth is impeded. So, in that sense, there is a strong connect between ecosystem services in terms of ecosystem utilization and with groundwater.
So, how do your findings challenges the assumption that more water availability through irrigation or shallow water tables always improve plant productivity and ecosystem health?
Typically, if the water tables are very deep or very shallow, it's not good for plants. The plants, typical plants, unless very deep-rooted trees, have need a shallow, reasonably moderate water table. If there is a lot of water logging, plants die. And similarly, if they are deep root, the plants can't utilize the water available is so low that water stress impacts the growth of the system. So for if the proper availability of water at a sustainable levels is critical for the functioning of the ecosystem, which is critical for the production systems and also regulating the climate.
So your study shows that groundwater depth directly affects how much carbon ecosystem can store. So how does this change the way we should think about groundwater depletion beyond drinking water and agriculture?
Yeah, I mean, agriculture and drinking water are the two major users of groundwater. But then we also should look at as I said, the ecosystem. The ecosystem in which we have the trees, we have the natural plants, and so on and so forth, very much depends on water. If they don't have the groundwater, especially during the lean years, because we always have in India with a tropical system and a monsoon driven system. Some years we have rain, some years droughts. So the groundwater is the only way which supports during the dry times of a year as well as during the drought years. So if there is no access of groundwater, all the natural ecosystem will be strongly impacted.
Sir, I read in your study that you mentioned about carbon use efficiency and water use efficiency help us better understand the trade-offs plant face between carbon uptake and water availability. So, what's your take about this?
So typically a plant when it wants to grow, it uses the both water and carbon. These two, water is the resource and the carbon is the nutrient resource which it has. So if there is a water stress which the plant can able to take, natural forest, natural grasslands, etc., they have to choose between conserving water and growth because water is not available. So, uh, the groundwater stress essentially forces some kind of difficult trade-offs, reducing plant efficiency and long-term ecosystem strength.
So, what are the broader climate consequences if large parts of India's ecosystem become less efficient at carbon repossession due to failing groundwater levels?
So typically ecosystems, if let's say an ecosystem is storing less carbon because it's unable to grow due to water stress, so we'll have more carbon remains in the atmosphere. We are always interested in carbon into the land. We want more carbon to come in. We want to stock carbon so that we remove the carbon from the atmosphere. If we have more carbon in the atmosphere, we all know that carbon is increasing. We are having various climate meetings where we are saying more carbon. So we would like the carbon to be sequestrated through this vegetation pump and ecosystem system as well. Otherwise, we'll have impacts on climate change, increasing of risk of heat waves, droughts. So the idea is a healthy ecosystem acts as a natural climate buffer,
Mm.
and groundwater depletion weakens that protection.
Okay. So if I ask as public point of view, so why should the public care about groundwater depletion as a climate issue and not just as a local water shortage problem? And what practical steps can citizens take to help slow groundwater depletion and protect ecosystems, carbon balance at local levels?
So generally for common public is looking at groundwater as a water source for their, but then we need to also bring a kind of an education wherein that it is also an important ecosystem, ecosystem health, and in which human is a part. And it also is important for us to understand that this ecosystem where we are functioning, it also is regulating all the services. For example, if my because groundwater is affecting how ecosystems absorb carbon and regulate climate, as I said before. So it can also can recover from extreme events like droughts, etc. So hence, the groundwater decline can weaken these natural climate services. So treating groundwater only as a water problem, then we will miss its associated impacts of climate impacts and so on. So we need to bring that also into our storyline that we are using it as a resource, but we also want to use this as a climate service function.
Well said. So, based on your research, what policy or government changes are most urgently needed to manage groundwater sustainably while also protecting India's carbon sink?
So I think everyone around in India are quite aware at the policy levels of, you'll see a lots of documents saying groundwater depleting, groundwater is an important resource. It has a connect between food, water, and energy. As I said, it's a strong connection. The connection with carbon is less known. That's why we did this study. So ideally, we need the policy implants are there in the country. We have been promoting reducing use of groundwater. We're looking for better and better practices of because agriculture takes away the large amount of water. We are trying to find better and water efficient use methods for agriculture, or promoting these technologies as well. We need to promote more. Okay, for example, probably we are trying to use instead of flood irrigation, maybe a drip irrigation. This is a structural reform. Similarly, there are methods like choosing, some states have already started watershed management programs in which programs looking at how to choose what kind of cropping practices are well suited for that region. So crop choice, depending on the climatic, agroclimatic regions. So all this becomes important to be able to reduce the too much utilization of water. That's on the supply side. And on the demand side, supply side also, we should also make some interventions. That means natural recharge may not be adequate, or the recharge is not happening at the right time. So we may have to reconstruct methods to increase our recharge process, and additional water, groundwater rejuvenation programs should be done. There are methods for improving the groundwater recharge process and so on and so forth. So all these would arrest to some level the groundwater decline. There has to be a social and community management method should be brought in, so that overall the groundwater depletion is followed or rather the policy ideas are implemented by the stakeholders.
Right. So, sir, if these timely actions are taken, so how reversible are the impacts of groundwater depletion on ecosystem productivity and carbon storage, and what gives you hope?
See, the groundwater is something, a renewable resource. So we have rains every year, we recharge, etc. Probably the recharge process may not be happening in the right way, or our usage has been not happening right way. So if you are following improved supply side processes and improved demand side processes, we are likely to improve our groundwater systems. So the moment in a particular region, if the groundwater is depleted, we will follow these steps through proper monitoring and evaluation methods. So one of the lacunas is that we have good policy methods, but someone has to do a lot of monitoring and evaluation to be able to see how is my groundwater construct in this particular region. Then we can focus our implementation of these policies in those places, not across the board. And once we do that, the groundwater will rejuvenate. There are lots of studies indicating that groundwater depletion some years ago has rebounded and groundwater has improved. So since it's a natural resource, you can improve the rebounding process. And if it is rebounding, in a few years, the groundwater levels will come up. If the groundwater levels will come up, my ecosystem will improve.
Yes, well said, sir. Any concluding note if you like to mention anything significant?
We should look at the ecosystem as well, along with our drinking and industrial needs. So ecosystem health also connect is important in groundwater. This is a message which is needed to be sent.
Right, sir. Thank you so much, Professor Shekhar, for sharing these insights on groundwater and carbon dynamics. So, understanding these ecosystems and their connections is vital for shaping policies that protect both our water resources and the climate. Thank you so much once again.
Thank you, Dr. Anubha.